But before that, I wanted to mention something else that Hubble discovered when he was proposing all his ideas in 1929. And so this is something that he did in conjunction with a different astronomer called Vestos Slipher. And this astronomer was observing the color of the galaxies in a few years before. And so at this point, remember, he does not know that the galaxies are galaxies. He thinks that galaxies are just like clouds of gas here in the Milky Way, okay? And he is observing these galaxies using a telescope and a prism. And if you don't know what a prism is, it's like a piece of glass that when the light comes into the glass, it splits up into its different colors, just like it makes a rainbow. Now, I know I don't know if you've seen like the Pink Floyd's, Dark Side of the Moon album cover, or if you've seen a literal rainbow, right? So like the sun's light comes in and it hits the water droplets in the air and it splits up and it makes the rainbow, right? So that's all real. That's all real stuff. So Vestos Slipher was observing the galaxies, which at this time he did not know that they were different galaxies, right? And he was observing them with a telescope and splitting up the light from those galaxies into different colors. And he noticed something weird. He noticed something that was different. He noticed that these galaxies were mostly more red than they should be. And what does that mean? So down here, I hope you can see my mouse. I have down here a black rectangle with some colored little lines on it. So this is the color of hydrogen. Hydrogen, the atom that would, the one that makes water like H2O, that hydrogen, if you put hydrogen on a lamp and you heat it up, just like a neon lamp, right? If you heat that up, it's going to make some color, and this is the color that you get. There's more lines, but these are the important ones. These are the ones in the visual spectrum. So these lines of hydrogen are made for every atom of hydrogen, it makes the same lines. Hydrogen over here, hydrogen on Mars, hydrogen in a different galaxy, they all make the same color because all the hydrogen atoms are identical. Okay, so this hydrogen that you make in the lab should be the same as the hydrogen in the galaxy that's far away. And so Vestos Slipher was looking at the colors of the galaxies and he noticed that the hydrogen and these galaxies are more red than they should be. And that is weird, but there is an explanation for that. So this is called the Doppler effect. And now I want you to imagine what happens when you're standing on the street and an ambulance comes rushing down the street, okay? And the ambulance has a siren on, and the sound of the siren is not the same when the ambulance is coming towards you as when it's moving away from you. And the reason for that is that waves change when the source is moving, okay? And so this thing is called the Doppler effect. So in the case of the ambulance, when the ambulance is coming towards you, the frequency of the waves of the sound of the ambulance siren become this frequency feels higher when it's moving towards you. And when in the case of sound, when frequency goes up, the pitch goes up and it sounds like more a higher pitch sound. So I'm not gonna make it, but lower pitch sounds sound like the lower pitch sounds, right? So when it's moving away from you, the frequency goes down and it gets to a lower pitch, right? Light is also a wave, and the frequency of the light is related to the color. And when the frequency goes up, it becomes blue, and when it goes down, it becomes red. And so what I'm saying is that when a source is moving towards you and emitting light, the light becomes blue shifted. It becomes more blue. If it's moving away from you, it becomes a red shifted, so more red. And so Vestos Slipher observes that many of these galaxies appear to be more red, moving away, okay? So he had 46 galaxies to work with. One more time, he did not know that these galaxies were very far away and very distant and very large. He thought that they were clouds here in the Milky Way. He observes 46 of them and he finds that most of them are moving away from us. And this, one more time, this is weird. Why should they do that? Because I thought that we just talked about how the universe is a place where here and there are about the same. And so if we're not in some local special place in the universe, some privileged location, then there should be no reason for all these galaxies to move away from here. That is weird. So Hubble comes in with the biggest telescope and he manages to find stars that are variable in 22 out of the 46 galaxies that Slipher had. And he manages to calculate distances to those 22 stars of those galaxies, right? So he has 22 galaxies that have a known velocity and a known distance. And so he puts them all in a graph, and this is what he finds. And this is literally the real graph that Hubble produced in 1929. The paper is still available. Yes, you can still find it. This is the real plot. He didn't have that much data, but he managed to make some important conclusions from this sparse data. So in the x-axis over here, what they have is distance, and on the y-axis is velocity. Parsec is a distance in astronomy that means 3.3 light years. So this is like a million, like 3 million light years, and this is like 6 million light years. So these are very distant places for us, and the velocities are pretty high, and clearly, the farther away you are, the faster you're moving away from us. This is weird. Why would that be? Why would it be that all these galaxies want to move away from here? What's so special about here? I thought that nothing was special about here. I actually spent the entire first half trying to convince you that there's nothing special about this place that we're in, right? So this is strange. This is problematic. If you want to know what this looks like today, because this is, again, this is a 100-year-old plot. This is a more recent plot, and nowadays we have the whole thing backwards. So like this y-axis where it says distance modulus, this is the distance now, and where it says z over here, that's the redshift, and the redshift is related to the distance and the velocity, but it's directly related to the velocity. So like basically the velocity is now on the x-axis instead of the y-axis, so they got flipped, right? But the plot that Hubble made is down here where my mouse is in the bottom left corner where it says 0. Like it's, if you take this and you divide it by like 1,000,000, that if you made a tiny little box zooming in like 1,000,000th in the corner, that's where you'll find Hubble's plot. So we have a lot more data now, and we can still confirm that what Hubble had observed is actually true. He was right in proposing with this very sparse data set that the galaxies that are farther away are actually moving faster away from here, for some reason away from here. That's weird. So let's think about the cosmological principle one more time, because there's implications to this idea that the universe ought to be the same here as it is far away over there. One more time, we were saying that because we think that there should not be a meaningful difference, that we shouldn't be in some special place, that no observer is in some special place that's privileged where the universe is different over there than it is over here. If that's true, then the universe should be more or less the same in all places, and it must look more or less the same in all directions. Now, what exactly does that mean? And we're going to go through them one by one. Okay, but one more time, the principle, the cosmological principle, is not a theorem. It is not a proof. It's something to be proved. But it's a nice, reasonable idea that we think makes sense.